Hey everyone, welcome back to the channel. This is Rahul. So, from today, we are going through Java memory model. Then we will go through try catch things. Then we will just give an intro regarding Java frameworks, collection frameworks. So, let's start. So, when you run a Java program, the Java Virtual Machine (JVM) will divide the memory into different runtime areas like uh, some session will store the class structure, some will store objects, some will store the local variables, some will track current instruction, and some will store the native method data like this. So actually we will give it in five session. First of all, the method area for metaspace. So actually, this one will store the class structure, static variables, and constants. Stores the class structure, static variables, and so that constants. Okay. Next one is the heap memory, which will shared across all the threads. Across threads, and it actually is storing the objects, arrays, and variables which are there in instance. Objects, then arrays, also the instance variable. Next one is stack memory. So this one is actually storing the local variables. Also, the method call frames like these things will store inside the stack memory. Also, the reference to a object like that it will also store in the stack only. Another one is PC registers. These are not that much important regarding DSA part. This stack and heap is much more important. So this PC register will track the current instruction of a thread that is processing at that moment. Instructions of a thread. And the last one is the native method stack. So this one also will store the uh, native means non-Java method data. So these are the five way which Java virtual machine will divide the memory when we run a specific program. So among this, we have to keep uh, learning regarding this heap and stack pretty much well, because during interviews they will ask most of the question from heap and stack memory, most cases. Okay, so we will just go through stack memory and heap memory much more uh, vastly compared to others. So stack is nothing but we are just storing the local variables, as I already mentioned, reference to an object. Also, the method call frames, which is the activation records in the memory, and it always follows the structure like last and first out, and which means if we keep one data at first, that can be keep out only at last. So that's regarding stack memory. In this stack memory, the local variables go away when the particular method ends. And compared to heap memory, this one is faster. But the issue here is it will cause stack overflow error, which we give so much nested calls inside a program. So it's limited in size. That's the issue regarding stack memory. So uh, the way that we are giving uh, storing a memory in storing one variable in stack is like, just think, I am just writing a particular program. So the way that it's stored in stack is when we are giving a local variable like index equal to 5. Okay, this is storing in stack. So now I will just show you how uh, the values are storing. Like just think, this is our stack. So first we are giving one variable initializing like int x equal to 5 uh, inside one method. Just take method A. Okay, in this method A, this is the first program that we are giving, first method. Okay, so if this is the first method, then inside you consider this as a stack now. Then it will store inside this stack like um, method A, then local x equal to 5. So this way it will store inside this. Next, if we have another second method, just to think second method, um, method B. Okay, so I'm just giving another variable like into y equal to 20. Then what will happen is it will store inside the upper, means if x is here then it will go for the top, like that it will store. Method B, local y is equal to 20. So this is the way that uh, the data storing inside a stack. So the last one will pop out first. The first that we inserted stored inside the stack will go at last only. So when there is no data, then there will be no active methods. When it becomes full, like consider there is one more method here, then it will give one error like a stack overflow error, which uh, um, if we give so many nested inside the code. So this is regarding stack overflow. Sorry, stack memory. Now we can go for heap memory. So heap memory I mentioned earlier. It's actually storing object, instance variables, and arrays, and it shares by all the threads that we are using inside the program, and it mostly managed by the garbage collector. So, which means the garbage collector is nothing but it will remove unreachable objects. If you have object 1 which is reachable and object 2 which is unreachable, okay, then what happens is actually this will runs automatically, this garbage collection. So uh, this garbage collection, when it runs, before it will be like object 1 and object 2 before running the garbage collection. Once it run, then what happen is uh, I will just before garbage collection, okay, after garbage collection. So after garbage collection, after we executing this garbage collection, what happen is the memory will get free space. We will free some space there, and we will only get the reachable data, that is the object 1, and we will get free space. So this what happens when triggering garbage collection. So the issue that regarding heap memory is like as I mentioned, it's slower because we are using pointer for referencing when it's needed. Also, the garbage collection will freeze the unused object, and the one we discussed for stack, which is the stack overflow error. Here here also we have one issue like out of memory error, which will occurs when the heap becomes full. So uh, here I am just creating one object. Okay, here this p is like a referencing, and we are creating new object, okay, which is in the heap. So what actually happening here is in the heap memory. Uh, First, we will save it the name Alice with the object. Okay, like that. In the next, we will save it as string. So this is happening in the heap memory. Like it's a string variable. Also, we are creating it as a object. So like stack, when the heap is empty, there will be no allocated objects. When it becomes overfilled, we will get the out of memory error. So this is regarding the Java memory model. So actually, the purpose of this memory model is like how the threads interact through the memory, which give the visibility and its ordering rules. So this is regarding the memory model. Now we can go through exception part, which is mostly we have to use inside our codings. Like mostly, I think most of you know what is an exception and all. So exception is like an event which disrupts the normal program flow. It's actually giving in three types like checked exception, unchecked exception, and errors. So this checked exception is like it will detect at the compile time only. The common example of this is like IO exception or SQL exception. In unchecked exception, it is like detected at the runtime only, which happens for the null pointer exception, arithmetic exception like that. Just I will give one code at catch. Okay, so here we have try, then we have catch. There is one more thing we can give is finally. Okay, so actually what happened here is in try catch we will give the code which is need to execute. Okay, so here this catch will go for the exception. If any exception we get during this, um, this code when we run this finally is giving, it will always execute. So it's needed when it's necessary. So no need of now. So when I run this code, see, I am getting arithmetic exception. So this is the use of this try catch. And yeah, the use of finally also we can mention like in a I will just give it how it's working. When we give a risky code in try, it will check whether it will run or not. If it is a exception, okay, exception, then we will go for if it is exception. 1 second. So if it is exception, then it go for the catch. Then it will execute the code inside the finally. Same time, if it is there is no exception, okay, there is no exception we got, then it will execute whatever in the finally. So this is what happens inside the try catch finally block. Mostly we will use this try catch only. Finally, will use when it's become that much necessary. So the rules that we need inside the try catch is like the multiple catch block can is allowed. Also, the finally will always run um, except in the system.exit or the JVM crashes. Also, you can rethrow the exceptions. So now we can start with collection frameworks, which we are using inside our DSA part. So this collection frameworks is actually so much important because to make it easy and to make it convenient, we have to know which uh, implementation, which interface we have to use like that. So the interface regarding collection framework is of four types: list, set, queue, and map. Among those, I will just explain three of them now. From each, we will use the implementations like from list. I will explain regarding array list and linked list now. That will be in a brief. In coming videos, we will explore it more because it's like a vast things we have to know about this collection frameworks. Then from map we will go for hash map. There is other things like tray map, dq, then hash set. These type of things are there. So each have their own functionalities regarding the usage and all. So first of all, array list. So you might be heard of arrays and all. The issue regarding array is like it have fixed memory. So when it comes to array list, the array size is resizable. So there is no issue with memory with respect to array list. Also, we have the data in a ordered way, but the uh, data that we are giving inside can be of duplicates. Also, there can be nulls. So these are the things regarding array list and the performance that array list showcasing is like we can access the data in faster manner and um, it shows some slow performance regarding the insertion or remove from regarding the middle list. So we can just go for one program regarding array list. So we will give it task like this array list with the type, then we have to give the name. So I'm just giving like a list. new array list. Okay, now how we can add data here is like the variable name add. Uh, so this way we can add the data. Okay, so once we add the data, if you want to fetch any data from this array list, you can give like list dot get in that way with the index mm, value. So I will just show you how we can do that. So if I have to get the second value, I have to give the value 1 and I run this code. See, we will get the data. So this is the way we can fetch all the we can save and fetch the data. Also, so many operations we can do uh, by using array list. So how it's saving inside the uh, memory is like I will show you how it is. So mm, index value. Okay, so for index 0 it will save my name. For index 1 it will save next value. So this is the pattern how it's saving the data. So now we can go for linked list. So linked list is like there are different types like single linked list, double linked list, circular, like that. So mm, it is actually a faster process for insertion and remove data, but when we have to access some data randomly, then it will be hard. So that's the issue regarding linked list. But the we will get data in ordered manner. Also, there will be duplicates in linked list. So let's see how we can uh, go for linked list. So like the array list, we can we have this linked list with the data type string. So I'm just using the same name. Now linked list. Like before, we can add the data. add first get. Okay, so when we run this code, we are adding dog and cat. So here, if you see, we are giving it as add first. So this cat will come at the first position. See, so this is what happening in linked list. So just see what will happen if we give see. This is the usage of some inbuilt methods. So just we will go deeper in the future sessions regarding linked list and all. So this is the way we are using linked list in our coding part. Next one is the hash map. So hash map is somewhat different compared to array list and linked list because here we will use one key value mapping. Also, there will be no ordering uh, like the array list, linked list. So the usage here is the key values will not have any duplicates, but we can have the values with the duplicates. Also, there can be one null key and many null values. So it gives a fast lookup with having a time complexity of big of 1. So it's somewhat faster compared to others. Let's see how it's writing hash map. So here we have to give the key and the value. So we can give the uh, thing like string and integer as the type. So I'm just giving name as map. So here how you can add the data like rather than add we have to give put. Okay, so like we given here we have to give one string and integer. So to get the data you have to use the method method get. So map dot get and we have to give the key as we given here. See, this is the way we can get the data. So I hope you understand how this works and all. So when we have to use this like array list, linked list and hash map is like array list can be used when there is many reads, few insertion or deletion in the middle. Linked list can be used when there are so many insertion and deletes and a few random reads. Hash map can be used when based lookup. So this is regarding the first part of Java fundamentals. From next session onwards, we are starting with arrays and string. Mostly we will start with array. because that's the first set which we will get somewhat confidence regarding DSA part. So see you in next video. Till that, happy coding.